Okay, so today we're going to be talking about arc length in radians, and it says our objective or our goal for today is to find the length of an arc in radians. So before we get started, we want to talk about what is a radian. So it says a radian is part of an arc of a circle that's congruent to the radius. Okay, it says there are 2 pi radians in a circle. How many degrees? So if we think about a full circle, you guys know that a circle is going to measure 360 degrees. So we would say 2 pi is equal to 360. Doesn't look like my pen's working very well. So 2 pi is equal to 360. So if I want to think about this like pi radians then, so I start here and I come around my circle, pi radians, what would pi be equal to? Pi would just be equal to 180 degrees. Okay, if I'm still talking about radians, what happens if I say pi over 2? So pi over 2 would be equal to, well, think of half of 180, 90 degrees. What about like pi over 4? What would that be as degrees? It would be 45 degrees. Now, you don't necessarily need to know how to convert your radians to degrees or degrees to radians. I just wanted to give you an idea of what a radian was. Okay, so what we're going to focus on today is arc length in radians, and the formula that you're going to use is right here. This is our arc length in radians. This symbol right here is called theta, and theta is just going to represent your central angle, and then r is your radius. So you take the measure of the central angle times the radius, and that's your arc length in radians. Okay, so the first one says the diagram below shows a central angle in radians of circle P. What is the length of arc QR? So what we said on the last slide is we're going to take theta times r. This time the theta is just pi over 3, and we're going to multiply by 7. Okay, now when I multiply fractions, remember this is like 7 over 1. Multiplying fractions, I go straight across. So pi times 7 gives me 7 pi. 3 times 1 just gives me 3. And then I can convert it to a decimal. 7 pi over 3 would be the exact value, so that's probably the best answer. But if they ask us for a decimal answer, we would just round it to like 7.33. And that's all we're doing for today. Okay, so another example. The diagram below shows a central angle in radians of circle P. What is the length of arc QR? So they're trying to find the length of this arc right here. Again, our formula is just theta times r, so theta is going to be pi over 4 this time. The radius of this circle is 12, so when I multiply, I go straight across. I end up with 12 pi over 4. I could simplify it and say I really get 3 pi as my answer, and then if we change it to a decimal value, I get 9.42. Okay. Next example, the diagram below shows a central angle in radians of circle P. What is the length of arc QR? Okay, so once again, just asking for that arc length. Sorry about that. Okay, so I'm going to go 2 pi over 3 times the radius, which is 5. Okay, multiplying the numerators, 2 pi times 5. So 2 times 5 gives me 10 pi. 3 times 1 gives me 3. So 10 pi over 3 is my exact answer. If I type it in, I end up with about approximately 10.47. I could be labeling these. I didn't do that earlier, but 10.47 millimeters. I should be labeling them. Okay, next one. The diagram below shows the central angle in radians of circle P. What is the length of arc QRS? So going from Q to R to S, showing me that this central angle in radians is 4 pi over 3. And I'm going to multiply by the radius, which is 11. Okay, so 4 times 11 gives me 44 pi over 3. Okay, and if I type that in, 44 pi divided by 3, I end up with would be approximately 46.08, and I could label it meters. Okay. Last problem for today, it says it's a challenge problem. It's a little bit from yesterday's lesson, a little bit from today. It says the diagram below shows circles P and Q with equal central angles. The radius of circle Q and the arc lengths in circles P and Q are given in the diagram. What is the length of the radius of circle P? Okay, so really we're saying this radius here is unknown. The central angles are the same, so we wouldn't want to compare the central angles. We know that those have the same measure. What we can compare between the two figures is, like, I could say that the radius of my first circle corresponds to the radius of the second circle, which is 5. Okay, and then I can use the arc lengths as well. So like the arc length here would be pi over 3, and it would correspond to this arc length, which is going to be pi over 4. How do I solve my proportion? Well, I'm really just going to cross multiply. That means I'm taking x times that pi over 4. So if I write this out, x times pi over 4, okay, if I put this over 1, I end up with like x pi over 4 for my answer. When I multiply the other side, 5 times pi over 3. 5 times pi over 3, it's just like what we were doing on the last slide. So 5 pi over 3. What do I know about these two values right here, this x pi over 4 and this 5 pi over 3? Well, they should still be equal to each other. So what I could do is write a second proportion now. I could say x pi over 4, set it equal to 5 pi over 3. And then once again, if I cross multiply, this time I get x pi times 3. So really I could think of it like 3x pi equal to 4 times 5 pi would give me 20 pi. Now from there, what's going to happen? Well, I could divide both sides by pi. Or I could divide by 3 pi right away if I wanted to do it in one step. Just my goal is to get x on a side by itself. So, well, the 3 pi would cancel. Over here, the pi's would cancel. So I could just say x is equal to 20 over 3. And if I change that to a decimal, I believe I get 6.666. I think so. Okay. And that is what we end up with for our answer. So for today, short lesson again, today's assignment is going to be your radians and arc length worksheet, which will be posted on Google Classroom, and you're only doing the evens today. Whoop, whoop, okay? Remember that you need to check your answers with the answer key on the website. Thanks, guys.